Hi everyone, how's it going? So today I want to talk to you about number 28 in chapter 8.3. And the question asks us to find the area inside the cardioid r equals 1 minus sine theta, and also outside the circle, and we're given r equals 1/2. And so when I first looked at this problem, I was like, oh my god, I have no clue whatsoever how to do this. But I'll work you all through this question, and after you get like the gist and the concept of it, it'll be fairly easy. Okay, so let's get started. So first of all, what we have to do is to draw a picture. And so here, oh, excuse me. And so here we have a pretty coordinates, Cartesian coordinate, and let's go ahead and draw the cardioid. It'll be centered at the origin and it goes all the way out. And that's just a rough idea of how the cardioid looks. Of course, my drawing is bad, but bear with me. Okay, so that's our cardioid of r equals 1 minus sine theta. And so our circle has a radius of 1/2 and it's centered at the origin as well. And so this will be our circle. And let's label what we know. And on the y-axis, this is 1/2, this is negative 1/2. And let's go ahead and find the intersection. So 1 minus sine theta equals to 0 because it's intersecting at the y-axis. And we'll get theta equals to pi over 2 or 3 pi over 2. So in this case, this is negative pi halves. Okay. So next step we're going to do is to find an intersection between the two r functions that were given. Intersection. So let's set them equals to each other. And so we'll get sine theta equals to 1/2, and theta will equal to pi over 6, oops, and 5 pi over 6. And so that's the intersections we get. So this right here is pi over 6. Okay, so earlier in the chapter we were given that the area of a region enclosed is equals to 1/2 of the integration of from alpha to beta f of theta squared d theta. And so using this formula, we can find our area of a half. So what I mean by a half is this area right here. Just a second, here, right here. Because going back to the question, we were asked to find the area inside the cardioid and outside the circle. And so what I just wrote of the equation is the area I just highlighted. So area of a half will equals to 1/2 from negative pi halves, so that's what we got right here, to pi over 6, which is the intersection. And so we have the outside function, which is 1 minus sine theta all squared minus the inner function, so it's 1/2 squared d theta. And so since this is the area of a half, the area of a whole, of the whole, is just simply 2 times the area of a half. So it's the integral from negative pi halves to pi over 6 of 1 minus sine theta all squared minus 1/2 all squared d theta. And so these two obviously cancel out, and we're left with this integral. Okay, so since we have already gotten the gist of it, we can go ahead and expand this, and we'll get 1 minus, we don't need the parentheses here, 1 minus 2 sine theta plus sine square theta minus 1/4 d theta. And so after you do all the algebra out, you will get 5 pi over 6 plus 7 root 3 over 8. So here you go.